Alright guys, Mr. Sareback here with e-learning assignment number 2 for March 17th. We're going to be talking about the worksheet. What is the difference between a barbell and an ocean? Alright. Before we actually do any examples on this worksheet though, just a couple things here. I took the video off of me, picture-in-picture there. I noticed there was some lag, and so that might be a little bit annoying to watch. So I took the video of me off. The second thing I want to do is I want to start every video with talking just a little bit about the previous worksheet. Now, I know the expectation was that you did not have to finish all 15 questions from yesterday's worksheet about the guy who jumped off a 100-foot tower, right? But some of you might want some closure on this. So, real quickly, what happened to the guy who jumped off a 100-foot tower into a large glass of root beer? Nothing. It was a soft drink. Alright, so if you were following along at home, maybe you were really worried about what's going to happen to this guy. It's a 100-foot tower, really high. Don't worry, guys. Just root beer, soft drink. Soft landing right there. Alright. So we're going to keep on going with this idea of factoring to reduce some of our rational expressions or rational functions that we're going to see. Here's the difference. When we take a look at this barbell and ocean worksheet, notice that there's two different fractions on each one of these problems, right? So we're going to have to factor this in a way that we can actually cross-cancel. Now, we want to take us back even if we were thinking about a problem like this. If I just had 2/3 times, just making up another fraction, we'll say it's 12 over 4, right? A lot of different ways to multiply this, but I want to encourage us to think about, oh, you know what? These two can actually reduce to a 1 and a 2. These two right here on the bottom left and the top right can reduce to a 1 and 4 respectively. And so my final answer is just on top 4 over 2. And again, I might be able to keep simplifying that down just to a 2. Okay? So that's something that I want us to encourage, right? We're looking at reducing common factors. Okay? Now, not all of our answers are going to simplify to not having a fraction, but I want to take a look here at number 5. And if we look at number 5, we want to look at the top left, bottom left, top right, bottom right, and see what or how each one of these individually factor, right? So if I'm looking here at the top left of number 5, I'm just going to draw my parentheses here. If I'm looking at the bottom left of number 5, it looks like it factors through there. Notice the upper right, and it looks like we just have a monomial on the bottom right, so that's not going to factor at all. Again, I want us to encourage us to always do what you think is the easiest of the 4 first to factor. Okay, so for me, I'm thinking, okay, these numbers have to multiply to be -10, but they have to add to be +3. So notice they do multiply to be -10, but these right here, this should be -2, that's what adds to be +3, not what I had originally. Alright, I can keep on going here. Bottom left, two numbers, they have to multiply to be +10, and they have to add to be -2, or add to be -7, excuse me. Same thing here, it looks like it's just a difference of 2 squares, so I know that it factors with x minus a number and then x plus that same number. Alright? Don't forget about this 5x, right? We always want to think about what is going to cancel here. So if I'm looking at what's going to cancel, it looks like I have an x minus 2 on top and bottom, always okay to cancel on the top and the bottom of the same fraction. And like we did before right here in this example, it's also okay to diagonally cancel. Okay? So if I look across the top left and bottom right, there's nothing that reduces. But I could look to see if a factor cancels that way. I'm going to try the same thing right here. it looks like x minus 5 will cancel on both the top right and bottom left. From here, it looks like I've canceled everything out. I just want to write what's left. It looks like the way that it's written here is that I have 2x plus 5, so I'm going to write that down twice. And then on the bottom, I just have a 5x. We could see that this is one of the answer choices that is given to me right here where my thumb is pointing. Okay? So that verifies that I have done the work correctly. All right? Let's take a look at one more example here. I'm going to move the camera down, and we're going to take a look here at number 11. All right, so number 11, again, we want to just go around. Again, we always want to look for a GCF first, right? So right here, it looks like there's a 5 with just a C plus 9 left over. Here, it looks like if I pull another 5 out, it looks like there is a 2C plus 9er left. I can go again to the top right, and it doesn't look like there's a GCF, but we could think about two numbers that might multiply to be 4c squared, and then two numbers that multiply to be 81 that add to be 0 in the middle. So this is how this top right would factor. Again, sometimes it just takes a while, guys, to take a look at how this is going to reduce, right? It looks like I have a C plus 9 bottom left, or excuse me, top left, bottom right. It looks like I have a C plus 9 right here, right? It looks like I also have a 5 there on top and bottom, both on the left. So what do I have that's left? It looks like there's just a 2C plus 9, or 2C, excuse me, minus 9, and if we notice right here in PL, that is the answer choice right there. Okay, so on this worksheet for a barbell, what is the difference between a barbell and an ocean? We've done two examples here for what I expect of you guys right here. And I just want to encourage you guys just to do the evens right here. So 2, 4, 6, 8, and 10, along with number 12. Please do not forget to include number 5 and number 11 in your work for full credit.